This is your video for the coordinate plane and transformations test review. Here's your answers. Some of them I just wrote them out that way you could see, because some of them you had to draw a picture, so you might want to pause it and check your answers. Alright, so talking about question number 1 through, well, it's really just question 1, and we have to plot the points on the coordinate plane. So S is -4, -2. So remember when we plot points, and my graph is really blurry, but yours on your paper is not. When you plot points, you always start at the origin, which the origin is here in the middle at 0, 0. So we're going to start at the origin, and we are going to, for S, we're going to go -4, which remember we always do the X first and then the Y. And X tells us left or right, and Y tells us up or down. So on this first one, we're going to go -4, so we go left -4, and then the Y is -2, so that tells us to go down 2. So for the first point, we are right here, and that's S. Then for T, the 0 means we don't move left or right at all. We just go up 4, so we're going to put our point right there, and that's T. For A, it's +4, so we are going to go right 4 and then -2, so we go down 2, and that is here. And then for R, it's -3, so we go left 3, and +2, so we go up 2, and that is right here. I was supposed to be connecting these dots as we go, so I was supposed to go here to here, here to here, here to here, and then for Z, it is +3, +2, so I would go right here, and there we go. I didn't tell you to connect back to the front, but if you did connect back to the first one, what shape did we form? We formed a star. Okay, for number 2, it gave you some pictures, and we're describing the position, and your pictures are much better than mine. But when you look at this picture, figure 1 is the front view, figure 2 is the side view, so our answer needs to say front and side, so it's going to be C. For number 3, it's going to be draw the picture from the side view, so from this perspective of where this arrow is right here. So if I looked at that, I would have a square on the bottom, and then I would see a triangle on top of it. Alright, so here's the next page. Number 4, which shape is located in quadrant 3? So remember when we label our quadrants, we always start in the positive, positive. So that's number 1. And then we go counterclockwise. So 1, 2, 3, and then 4. And they always label them in Roman numerals. So we're looking for quadrant 3. So the shape is a circle, because in this quadrant right here, the only shape that's there is this circle right here. For questions 5 through 7, we're going to use this graph, and it tells us to do a couple of things. First, it tells us triangle XYZ has coordinates, and so it gives us the coordinates. So before we translate, rotate, do anything, any type of transformation, we always graph the original figure. So -2, +5. It's right here. So that's X. 1, 5. And that's Y, and Z is -6, and then -7, 1, 2, 3, 4, 7. So here's where I got Z. So I have a triangle XYZ. It's kind of a weird looking triangle, but it's a triangle nonetheless. And it tells us to translate it given the following, and it tells us this right here. So remember, the X tells us left or right, and the Y tells us up or down. So on the x, if it's plus, we go right. If it's minus, we go left. On the y, if it's plus, we go up. If it's minus, we go down. So in this case, we have plus 3. So we're going to go to the right 3 places. So we know it's right 3. And for the y, it tells us minus 1. So remember, minus is down, so we're going to go down 1. So for each point, we go right 3. So I'm going to start with y just because it's over here. So I'm going to go to the right 3, 1, 2, 3, and down 1. So here's y prime. For x, I do the same thing. I go to the right 3 and down 1. And for z, same thing. So there we go. So now I have my new triangle, and it's x prime, y prime, z prime. So I just have to write the coordinates. So for x, it's going to be 1, 4. For y, it's going to be 4, 4. And for z, it's -3, -8. So the cool part about this is I can kind of check my answers. So x, my original x was -2, 5. So if I add 3 to -2, I get 1. If I subtract 1 from my y, I get 4. So I got that one right. So same for y, I can put my coordinate 1, 5. And my rule told me to add 3 to the x, subtract 1 from the y. So that would be 4, 4. So I got that one right. And then for z, my point was -6, -7. So if I add 3, that'd be -3. If I subtract 1, that'd be -8. So I also got that one right. So there's a way I can check myself. Sorry, in the background, you've already heard trains that went by my house, and now my dog's eating really loudly right next to me, so this is fun. Next page. Okay, so on this page we're doing scale factor. Before we start though, when I made my slide for this, I accidentally switched these measurements around. So on your paper this is 6 and this is 12, so that's how it should be. So when I do scale factor, I have to remember my formula is scale factor equals new over original. So make sure you have that memorized because you will need it. So it says that I'm enlarging shape 1 to become shape 2. So shape 1 to shape 2. So that means that shape 1 is my original shape, shape 2 is my new shape. So I'm going to label them appropriately. That way I don't get confused. So now when I do my scale factor, I have to find the two sides that correspond that I know both lengths. So in this case it's going to be the 6 and the 24. So I take my new side, which is 24, and I put it over my original side, which is 6. And anytime I see this line like this, it tells me I need to divide. So 24 divided by 6 is 4. So is my scale factor reasonable? Did shape 1 possibly get multiplied by 4 in order to make shape 2? Is it 4 times bigger? It looks bigger to me, so that seems to make sense. So that's a good, reasonable answer. So number 9, we're going to use the same shape up here, and we're going to find this missing side length for x right here. So remember when we did proportions, we had to, I always colored my corresponding sides. So now I'm going to set up my proportion. So I know 12, this pink side right here, goes with this pink side. So 12 goes with x. So now I know 6, this green side, goes with 24, this green side. So since I started with the original on top, I might even label original just so I know which one I did on top. I'm going to have to keep the original shape on top, so the 6, and then 24. So now I have my proportion. So I can just cross multiply and then divide. And when I do, I get 48 inches. But I'm going to tell you another way you could do this. Because we know our scale factor, I could take my original shape times my scale factor, and that would tell me my new side. So my original side was 12, and I can multiply that by my scale factor, which was 4, and that's how I could also get 48. So either way you do it is great. For 10, I'm just naming this transformation, and I even gave you the choices that you could choose from. And so because this shape, it didn't turn, it didn't get bigger, it didn't like flip over, so I know it has to be a translation. So remember, it did like a slide, and remember most of you told me that your teacher taught you that SL stands for slide, and so it just slid over and then down. Next page, we have rectangle ABCD is similar to rectangle EFGH, and mine's super blurry, but yours isn't on your paper. So we need to find the scale factor from ABCD, so we know it's our original one, to rectangle EFGH, so we know that's our new one. So remember, we just said scale factor equals new over original. In this case, I can choose whatever sides correspond that I know both. So I know that 6 goes with 15. I also know that 10 goes with 25. So this is possibly confusing because you're like, but hey, this one down here, the 10, it's on the bottom and the 25 is up on the top. But because it's a rectangle, I know if the bottom's 10, then the top is also 10. And this is a rectangle, so if the top is 25, the bottom is also 25. So now I can just take my new, so I'm going to use 25, so my new, and my original is 10. So when I divide 25 divided by 10, I get 2.5. So my scale factor in this is 2.5. So now I have to ask myself, is that reasonable? So is it reasonable that whenever I enlarge this, I multiply it by 2.5, so it's 2.5 times bigger? It seems reasonable to me. Number 12, I'm naming that transformation, and because it flipped over, it's a reflection. And you guys taught me that the FL in reflection helps you remember flip. And it actually reflects over the y-axis in this case, because it's right here. Write the coordinate for point J. Mine is almost impossible to read, but I know that this point right here is point J. So I always start at the origin, and then I ask myself, did I have to move left or right at all? To get to point J, I actually didn't move left or right at all, so I have 0. And then to get to point J, I have to go up, which means it's going to be positive, and I had to go up 6 places. So it's really hard to count on here, but it's 1, 2, 3, 4, 5, 6, and that's how I got that. Next page. I took a picture of some blocks that I made in my classroom, and I wanted to know what's the side view of the blocks. So the side view of the blocks is actually C. In my picture you can tell because of the colors, but on your worksheet you might not be able to tell. But just if it helps you, you could label this as the side. So I know that I have 2 in this side and 3 on that side, so it would be 2 here and then 3 here. This has way too many. This would actually be like from the back or the front, and this is from the top. This is the top. Okay, next question. A photo has the dimensions 5 inches high by 3 inches wide. If the photo is dilated and the new height is 15 inches, what's the new width? So there's a couple ways I could do this. I'm first going to draw a picture. I have a photo and it's 5 inches high and 3 inches wide. And then I'm going to get a new one. It's dilated and the new height is 15 inches and I want to know the width. So based on our last unit, we could set up my corresponding sides by coloring them, and I could just set up a proportion. So 5 would go with 15 and 3 would go with x, and then I can cross multiply and divide. Or if you want to, you could use scale factor. So I know this is my new and this is my original, so I could do 15 over 5. 15 over 5, 15 divided by 5 is 3, so I know my scale factor is 3. So if I know my scale factor, I can take my original side, 3, times my scale factor, which also happened to be 3, and I could get my new side, which is 9. It's the same exact answer as if you did it cross multiplying. 15 times 3 divided by 5, and you would get 9. So either way is a good way to do it. Oh look, number 16. What is the scale factor? Well, I just found it right here. So I did new over original. So I did 15 over 5. And I had to use 15 over 5 because those were the only two sides that I actually knew at first. So when I divide, I get 3 as my scale factor. Alright. Last page. We're going to use the graph that's super blurry. It says if point K is reflected over the y-axis, what would the coordinate for K prime be? Well, mine's really hard to read, but point K actually is right here. So this is K. And if I'm going to reflect over the y-axis, one thing I like to do is I like to draw a line like with a color, so I might actually do that. This is the y-axis. So if I'm going to reflect from over the y-axis, I have to take my pencil and I hang out on the y-axis and I count how many times did I move left to get to K. I move left 3 times. So to reflect it, I'm going to move right 3 times because whatever I do, I have to do the opposite. So that would be K prime. So that point would be 3, 1. 18 says, if point B was translated under the following, what would the new coordinate for B prime be? So B is located right here. That's B. And I have to remember what that means. Remember, X is left and right, Y is up and down, positive is right, negative is left, positive is up, negative is down. So in this case, it's x minus 4. So minus tells me I'm going to go left 4 times. And then this is plus 7. The y is plus 7, so that tells me I'm going to go up 7. So I'm going to take my B point, and I'm going to go left 4. So I go 1, 2, 3, 4. And then I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7. So my point would actually be right here. And that would be B prime. So the coordinates for B prime would be -2 and then 5. So remember, I can check myself because B started out as, I'm going to do it up here, to -2. So if I subtract 4 and add 7, 2 minus 4 is -2. -2 plus 7 is 5. So is that what I got right here? Yes, it is, so I'm good. Point number 19, if point C, which point C is right here, if it was reflected over the x-axis, so I'm going to draw my x-axis line, what would the new coordinate be? So to get to C, I went down 1, 2, and a half. So I'm going to do the opposite from the x-axis, and I'm going to go up 1, 2, and a half. So my new point is right here in the middle, C prime. So that coordinate is 3, +2 and a half. And then in number 20, I'm going to have to actually scroll down a little bit. If point J was translated under the following, what would the new... Okay, so here's our X is left and right. Right's positive, left's negative. Y is up and down. Up's positive, down's negative. It says X plus 8, so I'm going to go right 8. And then Y minus 12, so I'm going to go down 12. So I have to go find point J, so I got to scroll up a little bit. Point J is actually hanging out right here. So I have to go to the right 8 and down 12. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be right here, J prime. So on my paper it is going to be 8, negative 6. And I can double check that because my original coordinate was 8, 6. So if I add 8 and subtract 12 like it told me to, this would be 8 and negative 6. So is that what I got? Absolutely, so I know I got it right. Alright, if you guys have any questions, come see your teacher, and good luck studying for your test. See you in class.